You've been playing around with integration by parts lately, getting some practice with it, and I want to show you something really cool that you can do with integration by parts, and that is construct a reduction formula. And what is a reduction formula? Well, if we were to talk about this example here, the indefinite integral of ln of x raised to some power, well, a reduction formula is going to express this in terms of a simpler integral. So what I want to show you is we're going to apply integration by parts, make a reduction formula, and then apply that reduction formula to solve an indefinite integral of ln of x raised to some power. So maybe we'll do a higher power here, and I want to show you how that works. So to start off here, I want to throw some notation on this. We're going to say that this is equal to capital F sub n of x. All right, and then again, our goal is to apply integration by parts and to express this in terms of a simpler integral. So let's see how that plays out. Maybe you want to pause the video and try to apply integration by parts on this. All right, here we go. Integration by parts, and we need to find a u and a v prime. So we're going to let u, similar to how we apply integration by parts to find the indefinite integral of ln of x, we're going to let u be equal to ln of x raised to the nth power. And then u prime, taking this derivative here, this is going to be n times ln of x to the n minus 1 power. And then again, we have to go chain rule here, so this is times 1 over x. That's u prime. And then v prime, we're just left with is 1. And then v is x. Applying integration by parts, again, all of this under our notation is going to be equal to capital F sub n of x. So integration by parts, we go u times v, so that's going to be x times ln of x to the nth power, and then we have minus the indefinite integral of v du. So that's going to be x times n times ln of x, and then this is to the n minus 1 power, and then multiplying by 1 over x, and then integrating with respect to x. This is what we have from integration by parts, and this should all be review. But what can we see here? We're going to see that these x's are going to cancel, and then this n we can factor out. It's just a constant. So writing this out, let's see what we can find. So we have x times ln of x, and then this is to the nth power, and then we have minus n times the indefinite integral. And what we have left is ln of x to the n minus 1 power, and then integrating with respect to x. And this is exactly what we wanted. We said we want to express this in a simpler integral, in terms of a simpler integral, and that is what we have right here. This right here in our notation is what? If we were to apply this to our notation, this right here is capital F sub n minus 1 of x. And now we can write out our full reduction formula. So our reduction formula is going to be this. We have capital F sub n of x, and this is equal to x. I want that in purple. Let's try to get that in purple. This is going to be equal to, maybe, there we go, x times ln of x to the nth power. This is to the nth power, and then we have minus n times capital F sub n minus 1 of x. And this right here, make that a little nicer. This is x. There we go. This right here is our reduction formula. Right here. This is our reduction formula. And now we can use this to solve an integral. And let's apply it now. Let's say we want to grab some space, and let's use our reduction formula to solve an integral like this. So this is, maybe we can use it to solve this integral. Let's use it on the natural log of x raised to the third power. Let's do that. And under our notation, this is going to be capital F sub 3 of x. And now, in order to solve this, we're going to just use the reduction formula that we had. And how we do that is we just write it out pretty much. So wherever we see an n, that's going to be replaced with a 3 up here. And we have the following. We have x times the natural log of x raised to the nth power, and we said that n is 3 right here, so we have that, and then we have minus 3, let's check this out, minus 3 times capital F, and then we have to go n minus 1. So capital F sub n minus 1, so that's going to be 2. So we have times this here, capital F sub 2 of x. And then all we need to do, because again, we don't know what capital F sub 2 of x is, we use our reduction formula again. So we're going to come down here and find what capital F sub 2 of x is, and we just apply our reduction formula. Now n is going to be 2. So we have this. We have x times ln of x raised to the second power now, because n is 2, minus 2 times capital F sub 1 of x. And then we do that again. We find this here. So maybe we can fit it in right here. Capital F sub 1 of x. That is equal to x times ln of x to the first power minus 1 times capital F sub 0 of x. And then lastly, this right here, capital F sub 0 of x. We can just look at how we initially defined our notation over here. Capital F sub 0 of x is the indefinite integral of ln of x to the 0th power. And we know what that is. That's just 1. So this is literally the indefinite integral of 1 dx. And solving this is equal to x, and then we still have a plus c here. We'll just throw that in, we'll throw that on at the end. Because now this is the fun part. We just get to back substitute. We found what capital F sub 0 of x, and now we get to write down what capital F sub 1 of x is. This becomes x times ln of x, and then we have minus capital F sub 0 of x. We found that to be x. And just a quick pause here. What is capital F sub 1 of x? Well, if we go back over to our notation, that's literally the indefinite integral of ln of x. And we already know, we've calculated this before, that this is the indefinite integral of ln of x. So you can feel pretty good about that. Now, let's continue to back substitute. We found what capital F sub 1 of x is. Let's move back up a row, and we can write out what capital F sub 2 of x is. This is equal to x times ln of x to the second power minus 2, and then times everything down here for capital F sub 1 of x. So 2 times, and then we have x times ln of x minus x, and then let's get a pink parentheses on there. And then we move back up here, and we'll be finishing off our problem. This is what? This is equal to x times ln of x to the third power minus 3 times this whole thing down here for capital F sub 2 of x. Maybe I can copy paste that guy. We'll see if we can do that right here, like that. Copy, paste, copy. There we go. Move that guy up here, like that, right there. And then we'll throw a blue parentheses on. And we can't forget our plus c. We need to add on that plus c. But this right here is our answer. And you could go through and distribute some terms and simplify a little bit if you'd like. But this right here is our answer. And you can see this is a very cool application of a reduction formula, because after we found our reduction formula, the hardest calculation that we had to do was this right here, finding the indefinite integral of 1 dx. That is all. That is the hardest calculation we had to do. Everything else, we were just writing down our reduction formula and back substituting the previous value we found. So that is very cool. And in the upcoming videos, we're going to continue to work with constructing other reduction formulas and using them. One quick thing before we leave. If you've ever taken an introductory computer science class, or maybe dealt with some programming a little bit, maybe you're introduced to an idea called recursion. And whenever you write a recursive program here, this is kind of what you're going to see if you write out what happens. It leaves an answer and it comes back down, gets to a base case, and returns what it has to the previous calls that it had. So this is a cool analog to that. And if you end up getting into a computer science class, maybe you'll remember we talked about reduction formulas when they start to introduce recursion. So maybe a little connection there.